So this is Roopa Prasad, Assistant Professor, MCA, MITS College. So today we are going to discuss about the topic called as the file allocation methods. So these are the contents what we are going to discuss. First we go for the importance of file allocation. Then we go for the methods of file allocation, and those methods are contiguous allocation, linked allocation, indexed allocation, and finally multi-level indexing. These are the basic allocation methods. Okay, so first of all we discuss about the importance of file allocation methods. Okay, so file allocation. What is meant by file allocation? File allocation means the file has to be stored permanently on the system. So we are using the secondary storage in order to store all the files. So whenever we are going to store the files on the disk, you should be conscious that we have to use the disk space efficiently. For that purpose only, we are going for the different file allocation methods. So what happens? So efficient file allocation is very crucial for optimizing the disk space. That means what? In order to use the disk space efficiently, you have to make better use of the file allocation. So what it determines means it determines how the files will be stored and they are retrieved and how they are managed within the file system. So in order to have the disk space to be utilized properly, we have to use the different file allocation methods so that the system performance can be improved. Okay, coming to various methods of file allocation. So basically there are majorly there are the three methods are there. One we call it as a contiguous allocation, linked allocation, and the third one is called as a indexed allocation. In order to multi-level indexing is the improvised version of the linked allocation. Okay, that we will discuss later. Okay, so each method, these contiguous allocation, linked allocation, indexed allocation, all these methods are having some advantages as well as some disadvantages are there. So first we go through each and every allocation in depth. Okay, so the next one is contiguous allocation. So this is the contiguous allocation. So in contiguous allocation, what happens? We are going to store the file contiguously. That means what? The file will be occupied in contiguous blocks. That means, for example, here we are having a file called as a count. So this count file is having two blocks. Okay, so we are going to store contiguously. That means the first block will be stored in the 0th block on the disk, and second block will be stored in the first block of the disk. So we have to store the file contiguously. So each file occupies a contiguous sequence of blocks on the disk. So in the directory structures, what we are going to maintain is we are going to maintain the name of the file, and we are going to give the starting address where the file has been allocated, and we are going to give the length of the file in the blocks. Okay, for example, see, mail is the name of the file. So it has been allocated on the 19th block. So here from the 19th block, and it occupies contiguously 6 blocks. Okay, so 6 blocks are contiguously allocated. So 19, 20, 21, 22, 23 and 24. These are the mail file. Okay, so here what happens, in the name itself we can say contiguous allocation. So each file has to be contiguously allocated on the disk. Okay, so what is this main advantage? Means it is simple and efficient for retrieval. Okay, so we have different access methods like random access and direct access and sequential access. So it is suitable for both sequential access as well as a direct access. For example, if you want to access a file mail, okay, so we are having the starting address. So we go for the starting address. 19th block is the starting address of the mail, and here we are having 6 blocks. So we are going to have the sequential access. Okay, and it is very easy to retrieve. Suppose we want to have a direct access. That means what? You want to access the third block, then we know what is a starting block, right? So 19th is a starting block, and where is the third block? 21 is a third block. Like that we can directly access the file. Okay, so we are saying that it's simple and efficient for retrieval. But here what is the main disadvantage in this contiguous allocation is fragmentation. So fragmentation means as we are storing the files and we are removing the files, whenever we delete the file, what happens? The blocks will be again given back to the free space list. That means the block can be reused. Okay, so we are allocating and deallocating. We are storing and we are deleting. What happens? The disk space is divided into small chunks. That we call it as a fragmentation. So what happens? Suppose assume that here this 9 10 block. This assume that 10 11 12 13 10 11 12 is also filled. Okay, assume that 10 11 12 block is also filled by another 5. Okay, now what are the free blocks available? This 2 3 is available, 2 3 4 5 is available. Next 8 9 is available. Then 17 18 is available. 25 26 27 is available. Suppose a file has to be stored. The file is having 5 blocks. Okay, so what is the main condition of this contiguous allocation? We have to store the file contiguously. So what we have the file with the 5 blocks. Okay, and but here what happens, the space is not available contiguously, the space is not available even though we have the blocks 1 2 3 4, then 5 6 7 8 9 10 11. 11 blocks are available, but 5 blocks are cannot contiguously available. So that purpose we cannot able to store that file. Okay, that is the problem of the fragment, that we call it as external fragmentation. Even though we have the sufficient spaces available, we cannot able to allocate the space for the new file. Okay, so what happens for this one? The space utilization is inefficient. Even though we are having the space, but we cannot allocate. Why? Because the space is not contiguously available. That is a main drawback of the contiguous allocation. So that is a main disadvantage that is caused by the fragmentation. So what happens? So in order to solve this fragmentation, one solution is available, that is compaction. Compaction means what? Moving the blocks above. For example, you want to make it as 5 blocks. 5 blocks should be available, right? So what we can do? We can 8 9 is available. 2 3 4 5 is available. So we have to make contiguous blocks of 5 blocks. So what we can do means we can shift these 6 7 to 8 9, or 6 to 7 7 to 8. That we call it as compaction. But it is not always possible. It is difficult. It is some effort will be needed to have the compaction. So for that purpose, we can go for the another allocation method, that we call it as a linked allocation. Okay. So in linked allocation, what happens? Linked allocation uses linked list structures where each block contains a pointer to the next block in the file. That means what? We don't have to worry about wherever the blocks are available, whether they are contiguously available or not. We don't have to worry. What we have to do, whatever the space is available, there we can store the file. Another, for example, this is a file name called as zip. Okay, so it is starting at the 9th block. Starting at the 9th block. So we are storing the first block of zip file in 9th block. Then we search for another free block. So now the free block is available, where it is available at the 16th block. So we can store the 16th second block in 16th block. Then we can store the third block in first block. Then we can store the fourth block in 11th block. Like that we can able to store. Okay, that means what? Every block is linked to the another block. Okay, so there is no need to worry about the free blocks available. Wherever the free block is available, we can store the file and we can make up the link. Okay, in the directory structure, what we are going to maintain? We are going to maintain the starting address and ending address. Okay, here we are not going to give the length. We are going to give the starting address and ending address. So for this zip file, the starting address is 9th block and the ending address is 25th block. Okay, so when we go for the 9th block, we can find the address of the next block. Okay, because the block contains a pointer to the next block, and when we go for this block, we get the pointer to the next block, and we go for this block, we get the pointer to the next block, and finally we reach the final block. Okay, so this is a linked allocation. This we call it as a linked allocation. So what is the main advantage of this linked allocation? Is dynamic allocation. That means what? Dynamically we can allocate. At runtime we can able to allocate. Suppose if you want to increase a file, suppose if you want to add some more content in the file zip, then what is the ending 25, which contains a null pointer? There we can store the data and we can link to the another free block. Okay, like that we can have the dynamic storage. Dynamic allocation can be possible, which is not possible in the contiguous allocation. And it is suitable for varying file sizes. We can have any number of blocks in a file. Okay, but what is the main disadvantage? It is inefficient for random access, or we can call it as a direct access. It is only suitable for the sequential access. Why? Because we are having the starting address and we are having the ending address. So if we want to access the third block of the zip file, we cannot able to reach the third block. We have to go for the starting block. From the starting block we can get the address of the next block, and from the next block we can get the address of the second block. Then from that we can reach the third block. Okay, so direct access is not possible in linked allocation. Only sequential allocation is possible. Sequential access is possible. Okay, why? Because we can have the sequential. Each point, each block is containing the pointer to the next block. That is a main disadvantage of the linked allocation. And the space that is used by each block in order to store the address of the next block is also one of the disadvantage. Okay, so in the block, generally the block is of size 512 bytes. What happens, we are going to allocate some bytes in order to store the address of the next block. That is also one of the disadvantage of this linked allocation. So we can go for the another allocation method that we call it as a indexed allocation. Okay, in the indexed allocation it is similar to linked allocation, but what happens here, in the indexed allocation we are going to assign an index block to each file containing the pointers. So instead of storing the address of the next block in the previous block, we are going to dedicate one block in order to store all the pointers. Okay, that we call it as an indexed allocation. See, here zip is a file. Here we have dedicated 19th block as an indexed block. In the 19th block, it contains addresses. So, starting block will be in the 9th block. Okay, then from the 9th block, we are having the data in the 16th block. Then continuation first block, then 10th block, then 25th block. Okay, understand? And these are the null. These are the empty blocks. Okay, null pointer is the empty blocks. So here we can have, in order to have the direct access also, we are going to use this allocation method. Okay, so it is a linked allocation only, but in order to have the link of the pointer separately in each block, we are going to have it in one block that is called as a indexed block. So by this what happens, we can have the random access. We can have the random access to any block of the file. Suppose I want to have the third block, directly I can go to the index block and find out the address of the third block, where the third block is located in the first block of the disk. Okay, so it is suitable for random access. Sequential access is also possible. Sequential access, so what is the index block? 19. So what is the first block? Where is the first block located? 9th block. Where is the second block located? 16. Where is the third block located? 1. Sequential access is possible, as well as random access is also possible. We can have the direct access. Okay, and what is the disadvantage of this indexed allocation is larger files cannot be stored. Okay, larger file pointers. For example, we are having a larger file. Okay, the size of a block is 512 only. So what we have to do, we have to store all the pointers in this 512 block only. Okay, if it is a large file, we cannot able to accommodate. So for this purpose, we are going for the next allocation, that is multi-level indexing. Okay, multi-level indexing. So this multi-level indexing is mainly used to handle the larger files efficiently. So in this method, what we are going to do means the index blocks are organized in a hierarchical structure. So that means, so this is a inode, Unix inode. Here we see, for example, here we are having the data. Okay, that is a direct blocks. Okay, suppose indexed allocation is this one. That means what? If we are having a larger file, then we are going to store the pointers of the next index block. Okay, and the next index block, in this next index block, we are going to have the address of the data blocks. Like that, we can able to accommodate the larger files using indexing. Okay, so this allows for efficient access to larger files while minimizing the overhead of storing index information. Okay, so these are the allocation methods. These are the three basic allocation methods. One, we call it as a contiguous allocation, where the file blocks are contiguously allocated on the disk. And what are the disadvantage? Fragmentation is the main disadvantage. To overcome this, we have the linked allocation, where we can have the blocks in a linked fashion. And next one is indexed allocation. In order to have the store the larger files, we can go for the multi-level indexing. Okay, and these are the references from where I have made these slides. And if you have any feedback, if you want to give any feedback, or if you want to have any query, okay, so you can directly give your query to this form. Hope you understand. Thank you.